Welcome to this lesson on single replacement reactions. These are chemical reactions where one element swaps places with another element in a compound. The general pattern follows a plus BC yields a C plus. B this is one of the fundamental types of chemical reactions you'll encounter in chemistry, and understanding this pattern will help you predict how different substances interact with each other. A single replacement reaction is a reaction where one element replaces another element in a compound, forming a new compound and releasing the replaced element. Think of it like a substitution where one player swaps in for another. The key concept here is simple. One swap leads to one new product. The element that's being replaced gets kicked out and exists on its own, while the incoming element takes its place in the compound. Let's break down the general pattern A plus BC yields a C plus B here. A represents a single element on its own. BC represents a compound made of two elements bonded together. After the reaction occurs, we get a C plus B as our products. Notice how a replaced B in the compound, creating a new compound a C, while B is now released as a free element. This pattern is the foundation for understanding all single replacement reactions. There are two main types of single replacement reactions. The first type is metal replacement, where a metal plus a compound react. In this case, the metal replaces either another metal or hydrogen in the compound. The second type is halogen replacement, where a halogen plus a compound react. Here, one halogen replaces another halogen in the compound. Understanding these two categories helps you predict which elements can participate in single replacement reactions. Let's look at a metal replacement example. Zinc plus copper sulfate yields zinc sulfate plus copper. In this reaction, zinc is replacing copper in copper sulfate. The zinc atoms swap places with the copper atoms, forming a new compound called zinc sulfate and releasing pure copper metal. This reaction happens because zinc is more reactive than copper. The more reactive metal pushes out the less reactive one. Now for a halogen replacement example. Chlorine gas plus 2 sodium bromide yields 2 sodium chloride plus bromine gas. Here, chlorine is replacing bromine in sodium bromide. The chlorine atoms take the place of bromine atoms, forming sodium chloride, which is common table salt, and releasing bromine gas. This occurs because chlorine is more reactive than bromine, allowing it to displace bromine from the compound. The activity series is crucial for predicting whether a single replacement reaction will occur. The rule is simple. A more reactive element replaces a less reactive element. If an element is higher on the activity series, it will successfully replace an element that's lower on the series. However, if an element is lower on the activity series, it cannot replace an element that's higher. This means no reaction will occur in that case. Always check the activity series to determine if your reaction is possible. Let's review the key takeaways. First, in a single replacement reaction, one element replaces another element in a compound. Second, there are two types. Metal replacement and halogen replacement are both possible. Third, the activity series determines if a reaction will actually occur. Remember the pattern A plus BC yields a C plus B. Understanding these concepts will help you identify and predict single replacement reactions in chemistry. Practice recognizing this pattern, and you'll master single replacement reactions in no time.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.